We're going to use Google Sheets to calculate interest, future values, present values, payments, and all sorts of aspects of financial math. This is in a companion with the Math and Society textbook that I have here, provided by Portland Community College. Looking at Chapter 2, you can review a little bit of Google Sheets with 2.1 first if you're unfamiliar with using basic calculations, cell references, and the fill down feature. These will all be important to this video. I will show you how to do all these steps as well as I can, but if you get stuck or lost, I do recommend you to review 2.1 first. I'm just going to call this financial math, and I'm going to use the sheets down below to do a lot of labeling, starting with just simple interest. We'll have just two calculations that we'll make for simple interest. We'll be finding the interest and future value, or maturity value as it's sometimes called. We do interest equals principal times rate times time, and then we add the principal to that to find the future value. That's what they have here with A. To do the best job we can of labeling things, add a lot of labels at the top of these columns. I recommend putting the question or problem number followed by our inputs and outputs. Inputs, we have principal, rate. Rate could also be listed as APR. Time, which is measured in years. And those are our inputs. We'll have outputs of interest. And if you want, you can label these differently, shade them differently. In another video, I showed coloring input cells differently from output cells, and you can definitely do that with that fill feature. I'll keep this one simple though. And on question 1, we are just starting with a basic problem. I already did that one, so I'll do a new one. Here we have principal of $510, rate 7.5% for 8 years. What you'll notice is when you start typing these in, we don't have any formatting at all. So for example, my 510 doesn't have a dollar sign. If I try to do 7.5 without the percent, it doesn't really do anything. You can put a percent sign on and it will format it that way. But basically what I recommend is just format the whole column the way you want it. So if I click on column B and hit that dollar sign, it's going to format that as a currency. Column C as a percentage. Time, I don't need to format any certain way. Interest would be $, and future value in dollars. Column 1, there's no formatting needed, but one thing I do like to do is put this to the left alignment for the question number. So you can highlight that and align it on the left. Other things to note, if you have inputs in different spots than I do, the cell references will need to be adjusted. Let's look at this first problem. I had 8 years. My interest is principal times rate times time. You can definitely grab a calculator, type it in, 510 times 0.075 times 8, not a problem. The reason why we're doing it here is so you can do 5 or 10 problems really fast without having to keep calculating it. So to do that, we need to use cell references. Now, I usually just click on what I want. Equals brings up a formula. I need 510 times 7.5% times 8. So just clicking on it, using Shift 8 for that asterisk, that's the multiplication symbol, and just clicking on the 3 things I want. This gives me an interest rate. I'll just copy that little previewed number there, then I'll hit enter here to accept it, and I'll paste my answer there. If I try to copy and paste this, oftentimes it's going to copy and paste the formula and not the output, so that's why I highlighted that number above it. Now this interest rate will be the same for future rows down below, and I could even fill that down. I'm not going to take that suggestion, and I'm actually just going to undo that anyway. My future value will be the principal, that's B2, plus the interest in E2, $816. It didn't ask me for that in this problem, but as we go, once we get to problem 3, for example, we'll need to start finding that future value. So I'll go up to problem 3 now, not going in order, but that's okay. You can go in any order you want as well if you follow this video. Just make sure that we're still on a simple interest problem. This one's $10,000 at 3% for 8 years. This will show you how easy it is to modify 10,000, 3%, 8 years. Double check that you got everything right. Simple interest. And now to fill down, I already showed you, but here we can actually fill down both of these. You might need to click off to the side, but then you're going to want to highlight both of those like so. If you accidentally double click, it's not going to show you the option to fill, but our fill button is in that bottom right corner, and we can fill multiple cells alongside each other. So now we've filled down and we've got an answer for a future value to put into that next problem. We got that one. Now this is all going to work great. Problem 4, you have both of those answers, the interest and the future value. It's going to work great until you get to something like problem 6, where you see this compounding interest. I'm actually going to do these two problems in different sheets. This is my simple interest sheet. So I'll do 6A in this sheet. I'll do 6B in a new sheet. Let's start with 6A, 14,000, 8% simple interest for 10 years. Fill down those same formulas I used before. Figure out if it wants the future value or the interest. It wants the value of the investment, so that's future value. It'll be in that last column there, 25,200 for the simple interest. Now to find compound interest, I'll make a new sheet. If you want, you can start with the same headers. That will be just fine. The only thing I'll note is that typically we'll find the future value before the interest when we use this formula. We're going to be using the FV formula, which outputs a future value for all kinds of problems. It could be annuities, loans, investments, all kinds of things. So equals FV. You can see all the inputs there. You don't necessarily need to know those. Let's get it set up first. I have 6B as my problem number. Same principal, rate, and time. 14,000, 8%, 10 years. Notice how my formatting is not there like it was, so I'll make B dollars, C percent, E dollars, and F dollars. And it screwed up my rate. I've changed it to 800%, so I'll just retype that at 8%. Now my future value is equals FV. Put your parentheses, and the question mark will actually tell you what you need to type in there. Rate's the first thing. This is actually rate per period. So I realized that I don't have all the inputs I need. We go back here, you'll see rate per period, number of periods. You have an R over N and an N times T for those inputs. So we need a column for this N. I recommend putting it right next to rate, somewhere maybe before rate and time. Doesn't matter too much, just I recommend doing the same thing that I do in this video if you want all the cell references to be the same. I will put it right after my rate. So I have C, insert a column to the right of that, and I'll call this N. This is number per year, or number of compounds per year to be more specific. Usually it's just going to be 1 for that annual compounding. But it's good to have that here now because in future problems we'll look at quarterly, semi-annually, monthly, all kinds of different things. Now let's go back to that future value. Now I can input my rate per year. That's going to be C2 divided by D2. The 1's not going to change it on this problem, but it'll be good to have there for later. Then I'll do number of periods. Well, that's N times time. So you see C2 over D2, that's my rate per period, and D2 times E2, the next input is my number of periods. So you could imagine if it was compounded monthly, 12 times 10, that'd be 120 months, for that loan. Payments are actually zero here. There's no payments in this problem. That would only apply to a loan, mortgage, or annuity. Present value will be the principal in this case, and you may even want to relabel column B to say present value. And now we get our answer, but it's really odd because it's a negative. Why is it negative? I'm honestly not actually sure. I noticed that they have an example problem in the textbook where they have that same thing happen. That's why this is coming out in red and in parentheses. That's just like the expression in the red to show that you're in debt or in the hole. I guess you could look at it as if this was a loan, someone would owe that amount in the future if it grew and grew and grew without any payments. But we didn't start it as an owed amount, so it doesn't make complete sense to me. For me, all I do just to get rid of this negative is I put a negative in front of the FV formula because I just don't like having that differ. We'll find that the future value formula works great when payments are involved, but it could give us that flipped result when we don't have any payments there. Now to find the interest, I would just subtract. I'd take the future value minus the present value or principal. Like I said, if you want to change this to present value, that's probably the more common term when we do this compounding interest. This one asked for the amount at the end of the loan or investment. That's that future value right here. And we see that with the compounding, you get some more interest. That's because every year for 10 years, they're going to add on to the principal and continue to get more and more interest throughout the life of the loan. Now, if you go to number 7, you have a bunch of different problems in a row. This is where that N column is going to be really handy. Start by putting your present value, mine's 2,300. Your rate should be the same for all of these. I got 5.8% and 10 years. And I'll call these first 7A. Just looking at the annual compounding, it's giving me a problem with my N again. So I'm going to delete that value out, highlight the whole column, and format as an automatic number. Maybe that will take care of it again, and it looks good. Whether it will in the future, looks good for now. We will see when we get there. So I've got my annual interest problem here. The next one said semi-annual. That means semi through the year, halfway through the year. It's actually going to be twice a year. Quarterly's 4, monthly's 12. Daily, if we ignore leap years, that's 365 times. So you can actually put in twice a year, 4 times a year, 12 times a year, and 365 times a year. For these, just fill down what you've got. It's the same value for all of those. In this fill, I'm just using that bottom right corner as always. Here I've got 7B, 7D, 7C. Now for my interest, I already put in the formula. I need to find future value first. Future value uses all of those references. Try just filling it down like so. That looks good. This one looks good. Of course, I could have done them both together by highlighting and doing together. You can even double click, and sometimes that will snap fill and get you all the way to the end. Notice that increasing future value and interest with the additional compounding that's going on. It's not a ton different, but it is noticeable. And if you had a huge present value, you'd see bigger and bigger deviations there. Now, I already know that these ones are going to be right. I'm using my formulas, but let me quick just type them all in and double check to make sure. Should be looking at future values there. All those look good, so we can move on. Now that covers us for a bit. The next kind of problem that we have that would be different would be like number 9. And this one says, how much should we deposit now to have $6,000 in the account later? We can actually still use the same setup here. The difference is now we're putting a question mark here for present value, and we have a known amount over here for future value. Now it's up to you on if you want to create a new spreadsheet for this. If you did, I would recommend labeling it this way. This is compound interest, find future value. The new sheet would be a compound interest, find present value. So that's the distinction there. I will start by having the same top row, and I might even select that next row too. That way I get my formatting that I want included. The difference is here I'm going to start with a known future value, and I'll probably find the present value first and then the interest last. These formulas won't apply anymore. I'm going to be looking at problem 9 here with $6,000 at 7% quarterly for 5 years. So I have $6,000, 7% quarterly for 5 years. To find the present value, I will use the equals PV formula. This one again wants rate per period, number of periods, payment amount, and then we'll end it with future value. We won't ever use that end or beginning part here. Keep in mind we're doing rate divided by compounds, so that's C2 divided by D2. We're doing compounds times years for the next input. We have $0 payments, and we're looking for a future value over there in row B, in cell B2 for $6,000. You see that outputting value is negative, so if you want to throw a negative in front to cancel that, we should get our answer there. And it makes perfect sense. Oops, I made an error there. Let me get rid of that. There we go. Makes perfect sense that we would need to start at a value a little lower because it's going to be growing in between there. On this next type of problem, I'm looking at continuously compounded interest. And now we go down to using this formula. This is an exponential, EXP for that E exponential. Anytime we have this kind of continuous growth, we could call it exponential growth. It's also related to logarithmic growth or decay, tied with that E value. And it's a value that's kind of born out of calculus and these rate of change kind of problems. You could think of it as the natural rate of change constant. That's what we're using it for a lot here. And it will give us that continuous compounding. So it's almost like a trickle that's always happening where fractions of a penny are constantly being added on. If we want to go from beginning to end value, we take the principal starting value times e to the RT, where R is that annual rate and t is the number of years. So there's no n needed now in this kind of problem. I will again create a new sheet, and this is continuous interest. Where did that go? And that's kind of the downside to having these long names for these sheets, but this is continuous interest. Find future value will be first, and then we'll again flip it around for finding present value. A lot of the labels will be the same. I won't have n. If you want to again copy and paste what you had there, you can get rid of this column D by just highlighting it and deleting it. We'll use a new formula there. I did realize that I never found the interest on the last problem. Anytime you need to find it, just subtract future minus present and you'll get that too. Now for our continuous problem, let's put in the information. This is number 10. I have 5,000 at 7% for 10 years. We will, on this problem, start with a present value and end with a future value. It always helps to make sure that the thing you're finding is on the right. And I don't use the FV function. I really just build it up principal times EXP, inputting rate times time into the exponential. So there's the principal or present value, EXP there, rate times time, no compounds per year needed because it's continuously happening. And there we have our future value, interest. You can subtract the two. And now you've got a table set up to find future value for similar problems with continuous growth. I didn't see a problem in the homework section here where we had to find the present value with continuous growth, but I will go ahead and create that sheet too. I'm really just going to duplicate pretty much what I had in this one in that new sheet. Call this continuous. So if I have to find the present value with continuous interest, again, I'll flip these labels, future value and present value. And here's the difference really. Instead of multiplying, I just divide here. So I take the future value. Think of this as a growth ratio. It tells you that you're going to end up with a little over twice as much as you started with. So if we divide a future value by that, we would get our present value. And then I would just need to flip around my interest formula because I flipped around the beginning and end amounts there. Now it's set up to do any kind of problem. I do understand that you might like to do things differently. Zooming way out will maybe help you see all your sheet tabs at the bottom if that's too much there. You could maybe abbreviate these too. But this helps you quickly calculate all different kinds of interest problems for that 2.2 section.